Bismillahirrahmanirrahim. Assalamu alaikum. I'm Mrs. Tanzila Asim, lecturer mathematics, KMCG. The topic we are going to study today is nature of roots of a quadratic equation. All of you are familiar with a quadratic equation. It is ax squared plus bx plus c is equals to 0. The quadratic formula x is equals to minus b plus minus under root b square minus 4ac over 2a will give the roots of the quadratic equation. From the quadratic formula, the radicand b square minus 4ac will determine the nature of the roots. So we have come to know that for finding the nature of the roots, we will look at b square minus 4ac. Whatever be the value of b square minus 4ac, we will determine the nature of the roots of a quadratic equation. By the nature of the roots, we mean whether the roots are real or non-real, that is imaginary, or if the roots are equal or they are different or distinct or unequal. The radicand b square minus 4ac is called the discriminant of the equation ax squared plus bx plus c is equals to 0 because it discriminates among the three cases that can occur, and these three cases we will discuss today later. The formula for solving the quadratic equation ax squared plus bx plus c is equals to 0 is x is equals to minus b plus minus under root b square minus 4ac over 2a. This part b square minus 4ac is called the discriminant of the equation. Now if b square minus 4ac is positive greater than 0, after putting the values of a, b, c and after calculation, if we get a positive number, then the roots of this quadratic equation will be real and distinct. Means two different roots we will get, and these roots will be real roots. Now if b square minus 4ac is equals to 0, if this term becomes 0, we get minus b plus minus 0 over 2a. That is, the two roots we get are minus b over 2a and minus b over 2a. As this portion has become 0, then the roots are real and equal. How equal? Because this plus minus sign makes no difference because the value of the discriminant is 0 over here. So we will get two equal roots, that will be minus b over 2a and minus b over 2a. Now, if b square minus 4ac is less than 0, a negative number, then the roots are not real, because if we get a negative side inside this radical sign, what we get? We get imaginary numbers in terms of iota. So if discriminant is a negative number, it is less than 0, then the roots are imaginary, roots are not real. Now, summary is nature of roots of a quadratic equation. If discriminant is 0, roots are real, equal and rational. If discriminant is positive and also a perfect square. Now we are having two cases here. Discriminant is positive in both the cases, but either a perfect square or not a perfect square. If discriminant is positive and also a perfect square, then the roots are real, distinct and rational. And if b square minus 4ac is positive but not a perfect square, then the roots are real, distinct and irrational. So we have come to know if it is a perfect square, roots will be rational. If not a perfect square, roots will be irrational. Now, if b square minus 4ac is negative, less than 0. If it is negative, then we have already discussed roots will be imaginary, complex, not real. So for real roots, it must be equal to 0 or positive. In these cases, roots will be real, and if discriminant is negative number, then roots will be imaginary. Now, very easy way, a quadratic equation ax square plus bx plus c is equals to 0 has two distinct real roots if discriminant is positive, two equal real roots if b square minus 4ac is equals to 0, and no real root if b square minus 4ac is less than 0. So if we want to check nature of roots in terms of real, then look what happens. If discriminant positive, two distinct real. If discriminant equal to 0, two equal real roots. If discriminant is negative, no real root will occur. There we will get imaginary roots. Now, if discriminant becomes 0, look what happens and how. X is equals to minus b plus minus under root b square minus 4ac over 2a. Suppose that the value of b square minus 4ac is equals to 0. If it is 0, look what happens. One root will be minus b plus under root discriminant over 2a. If discriminant is 0, it will become minus b over 2a. And for the second root, x2 is equals to minus b minus under root b square minus 4ac over 2a. Discriminant is 0. Answer is again minus b over 2a. Hence, we get two equal roots of the quadratic equation if the discriminant is 0. And this is true biconditional. For example, if we are given that the roots of the equation are equal, this means discriminant will be equal to 0. And if we are given that discriminant is equals to 0, then we know that roots will be equal. Now, understanding the discriminant of real roots, number of real roots, looking at our discriminant again in terms of real roots. So discriminant is b square minus 4ac. If discriminant is positive, greater than 0, two different real roots, two distinct real roots. If discriminant is equal to 0, one real root, because two roots are equal, these are considered to be 1. If discriminant is a negative number, no real roots. What will we get? We will get imaginary roots, no real roots. Now, this is very important summary now. The roots of the quadratic equation ax square plus bx plus c is equals to 0 are x is equals to minus b plus under root b square minus 4ac over 2a, and x is equals to minus b minus under root b square minus 4ac over 2a. These are two different roots of the quadratic equation, where we take a, b and c as rational numbers. The nature of these two roots of quadratic equation depends on the value of the expression b square minus 4ac, which is called the discriminant. Now, case 1. If discriminant is equal to 0, then the roots of the equation are minus b over 2a minus b over 2a, which we have already discussed in our previous slides and we have proved it. So the roots are real, rational, repeated equal roots. Look, roots are repeating. Okay, now case 2. If discriminant is negative, less than 0, then there comes a negative number under the radical sign, inside the radical sign. So under root negative number will become a complex number. So if b square minus 4ac is less than 0, then the roots are complex or imaginary, and these roots occur in pair, one with positive sign and the other with negative sign, and these will be distinct, unequal, two different roots. Third case is very important. If b square minus 4ac is positive number, then roots will be unequal, roots will be different, roots will be real but not equal, two distinct unequal roots. However, if b square minus 4ac is a perfect square, then this radicand will be will be a rational number, and so the roots are rational and unequal. If b square minus 4ac is not a perfect square, then under root b square minus 4ac will be irrational, so roots will be irrational and unequal. So we have come to know, if we are having discriminant to be a perfect square, then roots will be rational. If discriminant is not a perfect square, roots will be irrational. Let's have some examples. Find the discriminant of the equation 3x square minus 2x plus 1 by 3 is equals to 0, and hence find the nature of the roots. Find them if they are real or not, equal or not. Let's see what happens. The value of small a is 3, b is minus 2, c is 1 by 3. We can also make our equation like this by multiplying the whole equation with 3. We get 9x square minus 6x plus 1 is equals to 0. Now comparing it with ax square plus bx plus c, or in other words you can say taking LCM and simplifying, we get equation to be like this. Now the value of a is 9, b is minus 6, c is 1. Finding discriminant b square minus 4ac. So after finding the value, after simplification, we get the value of the discriminant to be 0. So if discriminant is 0, then roots are real and equal. Yes, the nature of roots will be two equal roots we will get, as discriminant is 0. Let's see some more examples. The given equation is 2x square minus 3x plus 5 is equals to 0. Here the value of a is 2, b is equals to minus 3 and c is equals to 5. Finding discriminant b square minus 4ac, we get minus 31, which is a negative integer. Hence the roots are imaginary. Another equation is 3x square minus 4 under root 3x plus 4 is equals to 0. Here a is 3, b is minus 4 under root 3 and c is equals to 4. And the value of discriminant is 0. After calculation we have got the value 0. Hence the root will be, roots are real and equal. Now going to discuss some questions from your exercise. Question number 1, part number 1. Equation is 4x square plus 6x plus 1 is equals to 0, and we have to discuss about the nature of roots of this given equation. After finding discriminant, we have come to note that the value is 20, which is greater than 0. And let us check whether 20 is a complete square or not. No, 20 is not a perfect square. So the roots will be irrational, real and unequal. Look at second equation. X square minus 5x plus 6 is equals to 0. The value of a is 1. The value of b is minus 5 and the value of c is 6. Finding discriminant, we get the answer to be 1, which is greater than 0, positive, and 1 is also a complete square. It is perfect square of itself. Therefore, roots are rational, real and unequal. Now look at question number 2, part number 2. The given equation is b minus a x square plus c minus a x plus a minus b is equals to 0. Let us find the discriminant. Here the value of a is b minus a. Sorry, it will be c. b minus c. The value of b is c minus a and the value of c is a minus b. It must be c over here instead of a. So finding discriminant b square minus 4ac. What we have done? Opened the formula a minus b whole square and multiplying these two terms, we are getting these terms, and then more simplification. After multiplication with 4, the expression will become like this. Now opening the bracket, and after simplification the situation is a square plus c square plus 2ac plus 4ac minus 2ac will become plus 2ac, and these three terms will become a plus c whole square. Now, minus 4ab minus 4bc plus 4b square. So it will be formula of look, a plus c whole square minus, if we take 4b common, then it becomes minus 4b into a plus c plus 2b whole square. 4b square is equals to 2b whole square. So suppose x square plus y square minus 2xy. So it will become x minus y whole square. So you can see it has become a complete square. So as discriminant is a complete square, so roots are rational and hence the roots are real. And this is what we have to prove, that the roots will be real. As it is a complete square, so roots are rational and all rational numbers are real numbers, hence the roots are real. That is what we had to prove. Now question number 3, part 1. The given equation is p plus q x square minus px minus qb square minus 4ac is equal to 0. Now, finding discriminant, we have come to know that the value becomes p square plus 4pq plus 4q square, which is equals to p plus 2q whole square. Again, it is a complete square, so it will be greater than 0, and complete square means roots are rational and hence real. This is what we had to prove. Now look at question number 5. This is very much important question. We have to find the required condition when we are given that the roots of the equation are equal. Roots are equal means discriminant must be equal to 0. So, look at our question. First, we will make the shape of our question. So, the question is x square plus mx plus c whole square is equals to a square. Taking this whole square open by using formula a plus b whole square, we get the equation like this. X square will be taken common and then equation is of the form. Now the value of a is 1 plus m square, the value of b is 2mc, and the value of c constant term is c square minus a square. Now finding discriminant b square minus 4ac, after multiplication and simplification, taking 4 common, m square c square will be cancelled out and we are left with 4 times a square minus c square plus m square a square. As we are given in the question that the roots are equal, so we know that discriminant must be equal to 0. Putting this expression equal to be 0, as 4 cannot be equal to 0. 4 is 4. So this factor will be equal to 0. C taking c square on both sides and a square common, we have got the required result. Now look at question number 6. It is again the same question. We are given that the roots of this equation are equal and we have to show the condition. So you can see the equation mx plus c whole square is equals to 4ax. Taking whole square common and making the form of the quadratic equation. Now the value of a is m square. The value of b is 2 into mc minus 2a and the value of c is small c square. Now b square minus 4ac, taking the square of this term minus 4m square c square. After opening it by using formula a minus b whole square, we get the expression like this. Now plus m square c square minus m square c square will be cancelled out and we are left with it. As we are given that the roots are equal, so we must have discriminant equals to 0. So putting discriminant is equal to 0, we get 16a into a bracket a minus mc is equals to 0. As 16 cannot be equal to 0, so either a is equals to 0 or a minus mc is equals to 0. So a minus mc is equals to 0 implies a is equals to mc or c is equals to a over m, which is our required condition. Now question number 8 of the exercise. The given question is a square minus ba into x square plus 2 times b square minus ac into x plus c square minus ab is equals to 0. This is the given equation. And what we have to find out? So again, we are given that the roots of equation are equal and we have to find out some certain condition that should occur. So again, finding discriminant by formula b square minus 4ac, opening this for whole square formula by using a minus b whole square, multiplying these two brackets, simplifying the terms over here, and taking b common, we have come to know that the value of the discriminant is 4b into a cube plus b cube plus c cube minus 3abc. For equal roots, we must have discriminant is equals to 0. So we have put this expression is equals to 0. As 4 cannot be equal to 0, so either b is equals to 0 or a cube plus b cube plus c cube minus 3abc is equals to 0. So either b is equals to 0 or a cube plus b cube plus c cube is equals to 3abc. This is what we have been asked to find out, that we have to find out the condition if the discriminant or if the roots are equal, and hence the discriminant is equals to 0. That was all about the nature of roots of quadratic equation. Thank you and have a good day.